what are the benefits of a smart factory? Right? And how many of you would like that? Right? At the end of this program as well, you'll be able to find out, okay, does efficiency or is a smart factory, when once you implement it, right, does it really bring efficiency to your manufacturing lines? And how many of you would like that? Right? And of course, I'm sure that eventually, when you are efficient in your manufacturing lines, then you definitely want to make more money, right? From your manufacturing lines, right? Thank you so much. So before I move forward, right, please allow myself, all right, to introduce myself. So my name is Kenneth. I'm with Messe Worldwide. I've seen some familiar faces as well. Good morning. So we are actually the sales representative or the sales partners for SHRDC, right, for the Malaysian Smart Factory's flagship program. Now, what is interesting is we have done a lot. We've been doing this since, I think, mid last year, right, Dr. Chua? Yeah. So since mid last year, we've met a couple of our clients as well. We've consulted some of them. Some of them have already implemented some form of not some form, but have already implemented a few data generations along their manufacturing lines. Some of them are still considering. Some are still waiting to take the first step. Hopefully after today, then all of you can take the first step. Right? I think first and foremost, before we proceed further, what will be interesting is, rather than rushing through it, I think I would like to quote, I think Eddie Fong from Plasform, where he says that, what they do is they take their digital transformation one step at a time, right? So you don't need to rush to like 4 or 5. So I think under Industry Forward, you have this, 11 pillars in Industry 4.0. And everybody tells you must do 3 or 4 or 5 or even all 11 pillars at one time. But for a lot of manufacturers, and especially for SMEs, all right, doing 11 pillars is, I think, mind-boggling. Actually, first and foremost, to understand what Industry 4.0 is also mind-boggling itself. But to move forward, let's take one step at a time. Right? And this is where Dr. Chua and us, we are here to actually assist you guys to actually take that step one step at a time. Right? So without further ado, I will introduce Dr. Chua. Right? He's the man of the house, and he will talk about the smart factory benefits. All right? Thank you so much, Dr. Chua.
Okay. Thank you, Kenneth. Okay, hi, good morning, everybody. Thank you very much for being here at SHRDC. Oh, thank you. All right, thank you very much for being at SHRDC. I'm not sure if this is your first time to the Selangor Human Resource Development Center. If it is, welcome to SHRDC. So my name is Dr. Chua, and currently what I do is I manage this space called the Malaysian Smart Factory 4.0. And this space, basically, what we do for the industries is that we actually look at ways to help you to accelerate digital transformation strategies, right? And this digital transformation strategy is not so much from a perspective where we go to companies and then we say, okay, you want to do some form of data collection. So this is a solution that I sell to you. No. In a way, that also works, but the method that we go with is a more people-focused strategy. And why we do that is because we noticed that throughout the years of working with many companies, one key aspect of adoption of Industry 4.0 falls back to the people side of things, right? Whether you are willing to take the first step forward, right? And that's where understanding the benefits and also the costs related towards implementing a smart factory, and of course, to look at the benefits, you need to understand where are your potential losses first, right? Because if you don't know where's your losses, you don't know where to put in certain digitization to actually improve your productivity, and hence it will not be beneficial if you don't know where you are losing money, correct? So that's why the presentation is tailored towards ensuring that we understand the losses, the costs, and also the benefits at the end of the day, right? So Industry 4.0, if we look at the bigger picture of things, right, really focuses on moving the industries towards becoming a more data-driven industry, right? It's no longer about automation anymore. Automation falls back to Industry 3.0. Generally, you talk about robotics, you talk about automated machines, all these fall back into Industry 3.0. 4.0 takes it a little bit further, where we talk about the whole connection of the supply chain, right? That means from the raw material all the way to your customer, right? That kind of connectivity. And then you look at data-driven methods to actually improve productivity. So it's not so much of paper-based collection anymore. It's more about digitizing that to make it more transparent, more visible for the companies to actually understand where to improve on. Because without visualization, without any transparency in your productivity or your production, you don't know where to start, actually, right? So that's what Industry 4.0 really focuses on in a holistic manner. And if we look at the journey towards transformation, right, Industry 4.0 is not about a plug-and-play solution anymore, right? There's a lot of misconception when we go to, when I go to many events, exhibitions, webinars. I always see people ask about Industry 4.0 as if it is like a plug-and-play solution. But actually it's not, right? You can put in a device to collect data, but if you don't make use of that data, it's really not going to be beneficial for any company, right? So the whole idea is understanding that it is actually a journey, right? Industry 4.0 is a journey. And when you embark on that journey, there are phases of implementation or growth that you will expect, right? So what are the phases of growth that you will expect in your company? The first part, even before Industry 4.0, is you need to first think about connectivity. Within your factory environment, right, we talk about connectivity locally or public connectivity, right? We have seen many companies don't even have strong internet connection, right? They don't have strong internet connection. They went and purchased a very expensive solution, 200 over 1,000 ringgit to monitor IoT for some machines. That is a cloud-based system. That project failed. It failed. Why? Because understanding connectivity is not there, right? They don't have proper connectivity. They implemented a cloud-based system, and every day they only see a loading screen. So in that sense, the company did not prepare themselves well enough to actually ensure that they have the right connectivity. The next part of it, the consultant did not actually advise the company well enough to ensure that they have the right infrastructure before they start their journey. So there's already a mismatch in that understanding. So that's the first part. Once you have moved on from connectivity and computerization, then Industry 4.0 is actually moving to the step of gaining visibility. Now, what is visibility? Visibility talks about being able to see your production environment in a minute step, meaning to say that even when you sit down here or wherever you are in your office, you're not in front of your production floor, you can see what is the flow of your production. You know exactly where are the gaps. For example, you're supposed to start your machine running at 8 o'clock, right? But you only start at 8:30 from the data that you see. So what happened during that gap, right? That's what we need to find out, because we want to actually find out what are the gaps involved, and that's your losses. Because if you supposed to start at 8, but you only start at 8:30, what happened? You lost 30 minutes of time, right? So this is where visibility comes in. And if you're not sitting at the production floor the whole day, you will never know what happened. You will never know where are the gaps. All you know is, I'm supposed to start at 8. At the end of the shift, I will collect all the information, and then I will tabulate. Then I see, why my OEE or my productivity is so low. By the time, end of the shift, it's already too late, right? Because you could have done so many things to prevent that, but it's already too late, right? So that's visibility. Next part of it is transparency, right? Why? Right? So some companies, before they started digitization, what happened is that when they look at their production, they notice that, okay, there are gaps. Okay, there are a lot of gaps in their production, but they cannot verify whether the gaps is due to the data logger not being able to capture properly, or is it really the operator is missing in action? MIA, missing in action. So what they did was they actually installed CCTVs. not to really monitor the staff working, but to see what is actually happening at that point of time, to answer this question of transparency. Why? So when they install that, then they know, okay, the operator is really not there. The data that we collect is really accurate. And we know why the operator is not there. He took a long road to go and pick up a part at the warehouse, have a chat with a few friends before he came back to the machine. So if you're not at the shop floor all the time, you wouldn't know. But with digitization, that's how you can see or you know why is it happening. Now, with the data that you collect, right, from a day-to-day basis, you have a trend. Next thing to think about is what will happen, right? So for many companies, one of the key problems is always production planning, right? Production planning, scheduling, and optimization. Sometimes we may overplan, or sometimes we may be too optimistic and we actually plan too short that we never expect what will happen, right? So being able to anticipate, being able to predict what could possibly happen in a production plan will allow you to actually see where to plan it well enough, right? Because if you fail to plan, then we plan to fail generally, right? So that's why data is important. You get to see your trends. You get to know what is doable for you, what is achievable based on your current resources, based on your current machine capacity, actual capacity, not ideal capacity, and then you're able to plan moving forward. Then the last step is self-optimizing, right? Talk about adaptability. So if, let's say, machine is down, what can you do? How can you adapt to the situation, right? Because if you're not able to adapt fast enough, we also lose out, right? For example, if let's say I have this production plan, but suddenly my machine is down for 2-3 hours already, what can I do? Can I move it out, do a manual station machine, get it done, and then move back in? That is adaptability, right? So this is basically how the development path will look like towards achieving better productivity. So understanding your data is very important, right? And the whole goal of Industry 4.0 is really utilizing that data that you collect on a day-to-day basis to give you the information that you need. Because without that information, generally, it's very difficult for you to understand what is actually happening in your shop floor, right? So just now we talked about visibility, transparency, predictive capacity, adaptability. All these are information, knowledge, and wisdom. Because with wisdom, you're able to adapt. You know your shop floor. You are the owner of the process. You're the owner of the factory. You know what is happening. Knowledge, you need to know what is happening, why is it happening, before you actually take action, right? Information is what you need. That comes from data. So this pyramid of, this DIKW pyramid actually looks at that kind of data-driven kind of manufacturing process capabilities, right? So why data is so important, right? Generally, it falls back to why are we implementing Industry 4.0, right? Implementing Industry 4.0 is not just because we say want to call our factory IR 4.0. That's why we say, okay, we're going to put IoT, we're going to put AI, we're going to put AR, VR. No. It's really about understanding where are your losses, right? And with understanding your losses, you get to understand where to improve, right? Where are the gaps for you to improve? But it's always very difficult to find the minute, small losses that we are losing out that we don't realize, right? So for example, let's look at this graph over here, right? This actually explains very, very interestingly how people lose money by just losing time. Now, what I mean by losing money by losing time, there's only one single constant in a day, right? And that one constant is time. Every day we have 24 hours. Nobody has more than 24. Nobody has less than 24. It's a fixed constant. Everybody has that time, right? Every shift is fixed. 8 hours, 12 hours is a fixed time, right? Now, in that fixed time, we can either decide to be super productive or we can be really unproductive, Now, what do I mean by unproductive? Unproductive means that we have a lot of delay. And every day, without us realizing, we are delaying time, right? For example, the first part of it, knowing what happened. Now, if we did not know early enough that there is something wrong, right? Basically, we find out too late already. 1 hour, 2 hours too late. It's already delayed. We have lost time that we can actually use to do something. Next part of it, if we take a long time to analyze the situation, right? We don't know. We are new to it. This machine breakdown, we don't know what's happening, right? We have to call the maintenance team. Either you have in-house or external. Then, by the time they analyze, it's already taking too long. Because they don't have data, they don't know what to do, right? So that is another form of delay. Decision. Now, a lot of companies, they make decision, they take a long time. Why? Because they have to call everybody, team members, come, have a meeting. Take about 1 hour meeting, then we have to update the boss. Boss only will decide whether okay or not okay. Take another time delay. So all these are time delays that could be used to improve your productivity. And the last part, taking action. Are we ready to take action, or do we not have the spare part? Do we not have the right tools? Then we delay another action point. Okay? Now, illustrating this, let's look at a cost of running a factory example. Okay? Every day when you run your production, every day, every minute is actually cost, correct? Number one, you have your people that you pay a salary. So when you pay a salary, you pay by month, yes, but if you drill down to a minute, you have a cost for it, right? The moment you turn on your lights and you turn on the factory, it's already cost. Why? Because it's energy, right? Everything that you are running in a factory, every minute of time is cost, right? So assuming that your cost of running a factory is 1,000 per minute, assuming, okay? Now, if a machine is down, okay, and you take about 15 minutes to react to a machine downtime, that means the technician will run there, he takes 15 minutes, right? Because he went for coffee break or what, then he took 15 minutes to come. You wasted 15 minutes. You already wasted 15,000, right? Now, you need time to analyze the machine downtime, right? Without data, you don't know why the machine breaks down, why it's actually down. We don't know. There's no error involved. Then let's say you take about 1 hour, 60 minutes, right? You have lost 60,000 ringgit of time, worth of time, right? Making a decision, you take about 1 hour. You sit down, a meeting, you discuss, okay, machine is down because this. Let's get everyone's feedback. You lose time again. Time taken to fix the machine. We don't have the spare part. We don't have the right technician. We don't have the right maintenance team. We lost time again. So without us realizing, we actually lose time. And time is something that we can never buy back, right? No matter how much we have, we can never buy back time, right? So when you lose time because it is unproductive, there is a lot of expenses incurred, and basically you're just not being productive at that point of time, right? So the question is, how do we minimize all these form of unproductive time? We cannot cancel out, I would say that we cannot omit any form of unproductive time because sometimes it's just unavoidable, right? But what we can do is we can minimize it, minimize the impact, hence minimizing your actual cost incurred that is due to time delays. So digital transformation helps you to minimize that time. That's all it helps you to do actually, right? By putting in the right technologies, you are actually knowing your process better. You actually find out your gaps better, and you actually know what is happening in your shop floor to be able to prevent any unproductive time, right? Because let's say, for example, your machine has been always frequently down, right? But we don't know that frequency of downtime, right? There was one company that was telling me about that. Like, he didn't even calculate OEE. What he wanted to see was how many times the machine breaks down. He just wanted to see that part, right? And his focus was more on if I don't want to see this many lines, because I don't want so much frequency of downtime, I want to see a straight line only. Basically, it's a machine heartbeat, right? So if he sees so many lines, he knows that his machine has a problem. He needs to fix that first before he run another production, right? So basically, it's using data to see your factory, to give you eyes in the factory, right? And with real-time capability, you can see it clearer. You can actually fix problems faster, right? And that's how we effectively manage to fix time delays, right? So this is how, digital transformation or smart factory implementation helps you to actually save costs, right? Because without understanding where are your gaps, you can never improve your productivity, or it will not seem to be beneficial for your company, right? Now, of course, we understand that the major problem of moving towards Industry 4.0, we know roughly what it is. We know roughly what it can do. Yes, you got a nice dashboard. You can do some predictive capability. But question is, why is industries not moving forward? It's already 2022. Industry Forward launched in 2018. Germany talked about Industry 4.0 in 2010. So we are already 12 years from Germany and 4 years from the Malaysia launch. Where are we today, right? This is actually a survey done with SMEs by Smart Forward team. What they were looking at is why Industry 4.0 adoption in SMEs are not moving fast enough. It's not moving as fast as what is expected. Government give incentives, government plans some action plans, but why is it not moving forward? Now, based on the responses given by this survey, it's quite interesting. After 4 years of being of a launch of Industry Forward initiative, after 4 years of going through webinars, seminars, workshops, exhibitions, whatever we call it, or some companies doing readiness assessment, it is still surprising to see, right, that the main problem of not starting is many companies do not understand what is Industry 4.0 benefits, and they do not know where to start. They really don't know where to start, right? And another point of we don't know what are the available technologies that are relevant for their industry. Because factory owners, yes, you know how to run the factory, but of course we do not expect every company to be so tech savvy until you know every single technology out there or what is relevant, because it may not be your field, right? So this is where a lot of companies face that challenge, right? They do not know where to start. They do not know what is available for them, right? Then, of course, the next question is, what about cash flow? A lot of companies are affected by the cash flow part, right? They know that they need to move forward, but cash is a constraint, right? I've seen many companies, even they got approval for grant, the grant from MIDA, they say, I'm willing to let it go. They cannot afford it. Even an upfront investment, they cannot afford. Cash flow is a very big problem, right? And of course, also meeting the requirements of the grant. For example, you need to finish a project in 18 months, right? Today, with the global supply chain problem, there is a huge delay in hardware components by at least 6 months, minimum. We cannot find hardware. Even I also cannot find hardware, right? So is the timeline realistic? That's a big question mark. So a lot of companies say, it's okay, I will just let it go, right? So cash flow is a problem. Second point is know-how. They don't know where to start, don't know what are the technologies available. They really cannot see where it will add benefit for them. So they would rather not embark on it than to embark and then they think I might actually lose money, right? Because most of the industry's mindset is, what is my ROI? But really the question should be, what technology should you put in to save your costs, right? The third part of it is many companies go onto it without actually having the right people in their factory. Right people meaning to say that they don't have a team, right? They don't have the right technical people. They don't have the right technical know-how people in the factory. So they rely a lot on external party to support that implementation. Most of the time, I would say it's going to have a big problem, right? Because you have a lot of mismatch in expectation, you have a lot of requirements that you cannot fulfill. It's just going to be a very, very long process of discussion. It may not actually meet the expectation. There was one company that I met, like they say, we already engaged with somebody to do some form of implementation, but at the end, this is not what I want. So you see, there's already a mismatch in expectation. So because the company did not understand how to do things, how it connects, and they probably did not write down the requirements clearly. So that's why it did not work out. So these three parts are the main three key problems. And how to actually approach this problem to solve, right? It actually does not begin with technology first. Technology is abundance out there. You can see so much technology out there, right? You can see it from different countries, whatever technology that we want to implement. Problem is the people part, right? It's a people issue that needs to be solved, right? Why I say people first strategy is because, number one, leadership buy-in, right? There is a need for proper leadership buy-in, for them to understand the technology, for them to know the benefits, know the costs incurred, then only they can start. For the working level, right? Even though the management say, okay, I'm going to buy this very expensive ERP system for everyone to use, this is supposed to create benefit to the company. If the lower level people or the working level people are not using it, it's not going to work. Really, it won't work. Okay? Give you an example, also another one. I did a beta trial test with 3 companies. Okay? I told 3 companies, okay, SHRDC, we just launched our ERP system development, which we made it open source. Okay, open source meaning to say that companies are free to use that software. It's a full suite software, right? So I told company, okay, you can use it, you can explore it. When I went to the company, I said, okay, then they said, okay, we want to do it, but we don't know how to set it up and all that. Okay, never mind. To set it up is a very simple step. My team can help to do it. So we set it up for them, set up the server, set up the ERP software. To today, even though it's free, there's no one that uses it. Why? Nobody is really embarking on that journey to use it. Because why? They are not ready. So so it's not the technology issue, It's actually back to whether the people are willing to take that first step. Whether they are willing to take that first step to learn, right, how to utilize technology. Because a lot of them, I can say, with the day-to-day job, they are just not ready to migrate to certain systems. But those companies that are willing to do that, then yes, they will be 100% committed to it, right? But it starts with the top-level management. They need to drive the company to say, okay, we're going to do this implementation. Everybody needs to be on board. We're going to do this together, right? So that did not happen from many of the company perspective because, for the ERP case, because it starts with the working level. I just wanted to see if what is the hypothesis that I have, whether it was really true, that it's not a technology problem, but it's more of the people-focused problem, right? So understanding the phases of technology is important for the company, right? And in each phase, how can it create benefit for you, right? So in a smart factory architecture, we talk about operational technology as a first step. So what is operational technology? We talk about data collection, talk about infrastructure connectivity across the supply chain, hardware-software integration. So this is operational technology, the horizontal part, right? Then when you want to go to using your data for analytics and so on, that's when you talk about information system technology, right? You save your data into a database, you save your data into the cloud, whether it's a private or public cloud, that is information systems technology. Then you talk about analytics and AI, that will be the second part of it. Now the third part of it, which is now also quite essential, right, for many companies, although they may not realize it, is the digital factory, right? Now, most of the time, companies, when they plan their factory layout, it is, okay, you have how many square feet space, and of course, when you start up, you buy a few machines to place first. Then eventually, when you continue to upgrade, you just place. But eventually, it's not the most optimized, right? So digital factory looks at that kind of optimization of how you will see your factory flow. Later, I will show you one use case, okay? Now, concept-wise is we need to ensure that whatever we implement are modular, scalable, flexible, and compatible. Why? Yes, you implement technology, it brings benefit, right? It brings a lot of benefit to your company. You see that it reduces costs. Now, question is, 1 year, 2 years down the road, can you scale it up? Can you add more machines? Can you easily connect your machines to your software, your ERP, manufacturing execution system, anything that you name it? Can it easily scale? Because I've seen so many companies, they buy the best and the latest machine, the best in the world out there. First question I ask them, how will it connect? I don't know. Right now, I have this one machine that is IoT capable, can connect to the cloud. Everything is all good. What about your other machines? Don't know. Probably we need to change all of them. So you see, that's another problem, right? You are being brand dependent. Therefore, it's not modular anymore. It's not scalable, right? And it's not flexible, it's not compatible, right? So a lot of companies may not realize it because when they buy, they think, okay, this is the most advanced out there. I need it, and these extra features, later I will think how to connect it. But most of the time, it ends up with it being working in silo, right? And some surprising facts is that when I talk to some companies as well, a lot of their machines are connected to the cloud, like Azure, Microsoft Azure, and all that. When I ask them, okay, how much is the cost for your cloud implementation? They told me, oh, this year, first year free, because I buy the machine, so first year is free. Second part is, how much is the cost after this first year? I don't know. That one is a very dangerous part. Because if you don't know, you may stop the service. Everything else will no longer be flexible, scalable, compatible anymore. So this is what companies need to understand when they implement technology. So to make it more beneficial, you need to know what you're investing in, right? And the whole idea is you should not be investing in something where it gives you the headache for the next 5 years, right? Like there was a company in Johor, they started ERP implementation 10 years ago, right? And the managing director said that it was the worst headache he had for that 10 years. And today, he migrated to another ERP system. I don't know if he will have another headache for the next 10 years, right? So the whole idea is understanding the concept of Industry 4.0 is not about being brand-centric, right? When you invest in technology, it needs to be brand neutral, right? You need to know how things connect to each other, right? And every machine has a single language that they talk to each other on. It's not magical, right? Machine A, machine B talk to each other. There's a single protocol one, right? Every machine is like that. But most people, when they buy machines previously, they did not know that there is such connection. Therefore, they forgot to ask the provider to unlock that particular connection. So because they did not unlock, two machines cannot talk to each other. So that's the main problem for many industries, right? In the semiconductor industries, it's even more interesting. Like we have, I heard of stories where in the semicon, they use this protocol called SECGEM, okay? SECSGEM, SECGEM protocol, right? It's supposed to be open, but it is actually a very proprietary protocol that is only understood within the same semicon industry, right? Now, what is interesting enough is that if you manufacture a machine that provides SECGEM protocol, basically the next machine, if you want to buy another different brand, unless brand A allows you to talk to brand B, you cannot connect. So one of the companies say it's like they are held ransom to that particular machine provider. So this is why understanding the open protocol when you buy machine, invest in technology is very important, right? The third part, open collaboration. What does it mean? Industry 4.0 no longer talks about working alone anymore. So every brand that you buy, there is definitely an approach where you can connect things through a community approach. What do I mean by community? We talk about the open source approach. So there are a lot of open source technology that many companies in Malaysia are not aware of, or they are not kept aware of because many of them did not explore that opportunity. So of course here we work a lot on open source tech. So I will show you how it all works, right? Now the fourth point, rapid prototyping. When you want to implement technology, you don't want to spend too much time, right? Because time is money, correct? So how you want to see technology implemented, it has to be fast, right? So basically when you implement certain tech, it needs to be fast. Maybe 1 month, 2 months, it should be up. But I've seen many companies to even digitize one machine, took them 6 months, which I don't understand why. So this part is what we talk about in terms of reducing the time to deploy. So understanding this structure helps you to now understand how it could bring more benefit because you are now, you know the technology better, right? And when you want to implement that whole smart factory concept, you need to understand how it connects horizontally and vertically. Actually, the key problem that many industries face is not about the technology, it's about understanding how it talks to each other. So if you do not understand how it talks to each other, most of the time you will buy software A, cannot talk to each other. Software B, cannot talk to each other. C, D, E, cannot talk to each other. So you're stuck already. I've seen so many companies, okay, for some particular reason, I don't know why, ERP is equal to accounting software in many industry mindset. Actually, it's not. It's a wrong connection, right? But many accounting software, maybe they brand it as, I sell you accounting software, I have a ERP included inside. But it's actually not the real ERP. The real ERP is supposed to connect to the shop floor one, but theirs cannot, right? So many accounting software have, Malaysia, they buy a lot of accounting software like SQL accounting, AutoCount is quite popular. Problem now, when they want to implement another ERP, is they don't want to let go of the API. They don't want to allow company to connect to their software. So when you invest in technology, always ask what is the connection. Otherwise, it's very, very difficult for you to move forward. Yeah. So this one, not many people will tell you, but this is happening on the ground. Because we work with many companies on looking at their factory implementation. It's happening like this. These are the key problems that are happening in the ground. So unless you understand how it connects to each other, it's very difficult for you to know where to start, right? Or what to ask for when you want to buy technology, okay? So then understanding your stages, right? Just now we talked about one problem, which is knowing where to start, okay? So many companies think that Industry 4.0 is like you can go AI analytics will solve everything for me. I've seen people tell me that. But first question I ask is, how about your data? Where is your data being collected? Oh, sometimes it's there, sometimes it's not there. My operator or supervisor will collect it at the end of the day, put it into the system. That is not automating your data, right? Then next question I ask, do you actually know what is happening in your floor? No, they do not visualize. They do not store, they do not formulate, and how would we then go into analytics and AI? So the first step is collecting data first, actually. Like, we don't need to think about the bigger picture too big, right? But start by looking at where are your bottlenecks first, right? For example, one company, he don't even want to think about OEE first. He said, OEE is the last step for me. But I want to know how many times my machine breaks down in one day. He just wants to see that frequency. So data generation is enough for you. because he wants to visualize and he wants to generate data on it. So step by step, when they are ready, then they move forward. When they're ready, then they move forward. So from a factory floor perspective, right, generate data, go up to visualize, store, then only calculate your OEE, then only do analytics. So it's a step-by-step approach. Right? Now, why we have two different ways of collecting data? Because many machine manufacturers don't allow us to connect directly to their machine, their controllers. A lot of them say, no, cannot open, cannot touch. You want to open and touch, can, pay extra. So that's why this method only works if companies are developing their own PLC programming, right? Now, we have another way, which is retrofitting. So retrofitting then allows you to collect data from machine without actually touching any of the codes. So this is what we call as digital retrofitting method. And somehow this is the most popular method or popular program that we have for our Smart Factory program, because most companies are retrofitting, right? Especially for legacy machines, right? So how it looks like for retrofitting, right? So company just needs to know what data that they need to collect. So in order to be able to reap benefits from your implementation, okay, reap benefits, you need to know what data to collect first, right? If you don't know what data to collect, we won't know how beneficial that data will be for you, right? You'll be just collecting, some data, and then you say, after that, I don't see where to improve, I don't see how to improve, I'm just collecting data, right? But you need to collect data that provides you with information of your downtime, right? Your performance, and your quality. These are the three key areas for you to improve, right? Because if you improve your downtime, you actually, cut off a lot of unproductive time. If you improve your performance, that means your machine is actually moving faster. You get to churn out more products at a given time. Quality, a lot of companies may have quality issues. We want to cut that down, because any form of rework or quality issues brings cost, right? Because you have to do cost of rework and so on. Now, then once you understand what kind of data that you want to collect, next step is knowing what hardware to use, right, to collect those information, right? And most of the time, companies think that, Industry 4.0, to buy hardware is expensive, the solution is expensive. Actually, not expensive. Hardware is not the most expensive part, to be very frank. Okay, I recently was talking to a computer vision hardware provider. They were selling cameras for vision inspection. So they were showing me, okay, this camera can do this, that. Okay, how much is the camera? Camera is about 5,000. Okay, then they were showing me their software can do all kinds of things. How much is your software? Software starts at 15,000 up to 20,000. So which one is more expensive? The hardware or the software? So hardware is actually not expensive at all, because hardware is more standardized pricing one, more or less. And now with the global supply problem, we need to be able to be brand independent, meaning to say that if Siemens don't have stock, I can still go forward. I can still choose another brand that is not Siemens anymore. Maybe I want to choose Avantec, maybe I want to choose Omron, right? But if we are still stuck with, I must use Siemens, then it's very difficult, right? So this is how we talk about brand neutral approach. Now, software side being more expensive, there are also possibilities for companies to implement their own software at the cheaper side of things, right? So this is what we talk about, the open source approach, right? Whereby you can actually build your own technology for your factory. You can actually see your data fast enough with low upfront investment so that you don't feel the pinch if it doesn't work, right? Generally, it should work, but at least when you want to invest in something, it wouldn't seem like it's a very big hole in the pocket, right? So assuming that you want to start one project, right, it can be less than 10,000 ringgit to actually get up a OEE system running. So that's how cost effective it can be. But of course, with this, it comes with a bit of effort that needs to be done from the company perspective, right? Then only you can build your own systems like this. Once you build systems like this, why do you want to calculate OEE? Like, people will be asking why you want to see this kind of data. It's actually to identify losses, right? Losses. Why? Because losses equal to cost, money. So if you can identify all your losses, then you can actually find where are your leakages in your company that you cannot see initially. Now it's clear. And then you can actually find ways to cut all the losses. So OEE is a metric to actually see how productive you are. If you are at 60% not so productive, then you want to move to 70%, 75%, 80% to become world-class, right? And of course, when you want to get your customers to buy your product, of course, to show them these reports or this report card, right, will always seem a bit more interesting for them, right? Wow, you have an actual report card of your OEE. You actually monitor your data on a day-to-day basis. It creates assurance to your customers that you are putting their best interests into building their products for them, right? Because everything is data-driven. You have invested in a data-driven methodology to move forward, right? So there needs to be a reason to why you implement technology, right? If there's no reason, then it's not worth it for you to invest in. So when you want to implement technology, you need to make it simple, right? It shouldn't be complicated, because the moment that you think it's complicated, it's going to make you think 5 times before you invest, right? So how technologies have evolved, right? From the early days, even as early as when I was doing my university studies, right? When we want to implement technology, we have to write lines and lines of codes. 100 lines of codes to get one dashboard like that. Today, a few blocks, you already get a dashboard, right? So this is what we call evolution of programming, evolution of technology, moving towards what we call as low-code development. So we have had people where they come and learn, they go back, they implement this technology within 1 day. Just connect things together, already up, running. So that's how fast technologies can move industries, only if they are willing to explore, right? So then, when you want to move your technology, when after you finish the first project, let's say you've done 1 machine OEE, you don't want to stop there, right? You want to see holistically your whole factory, how to implement it. So that's where then you have, you can scale up from 1 machine, 2 machine, 3 machine, 4 machine, 5 machine. You need to know how it all connects in that ecosystem. And the software that you invest in has to be able to cope with that, right? So which is why when we work with the software development, we make sure that it's always able to scale. Because the moment that it's not able to scale, we have a big problem, right? Because companies will come to me and ask me why it cannot connect, why it cannot move up, why it cannot scale. So, different companies have so many different ideas for their production. For example, the company A that we supported for their project, they never asked us any additional requirement for their reporting. But the same group of companies, just different factory, the other factory asks us, can you now do an email reporting of my day-to-day OEE or not? So the earlier company did not ask for it, the second company did, which then we need to come up with a way to actually do that email reporting. So you see, every company has different ideas, different way of what they want to see, even though they are in the same group, right? But this is good. This is what we encourage. Why? Because this encourages innovation within the company. Because they feel that, okay, if I have a reporting every day of the OEE, at the end of the shift, I get a full report, send to managers, send to boss, send to everybody. I know everything already. I don't even need to go and ask my guy, oh, today what's the OEE? Yeah? Another company was saying, oh, I enough already. In my WhatsApp, every 6 o'clock, I will get my report. But that's not the right way to do it, right? Then ERP integration, right? Some companies, they want to buy ERP systems. Yes, go ahead, no problem. But question is, every company needs its own customization. I've seen so many companies that I talk to about ERP, right? Not one of them is the same one, right? So question is always select your software that is customizable. And customizable not by relying on other people, but relying on yourself to customize, right? For example, you want to see it this way. No problem. Change this parameter, then deploy the workflow, right? So when we select software for even like ERP, right, we also make sure that it is ultimately customizable, right? And a lot of these software are already available out in the open, right? Today you go back home, I give you all the links you can download already and use. Just go ahead and use. It's okay. Most importantly is knowing how to use it, right? Because many companies, the problem is they don't even have a proper process flow. Identifying a process is very important. Like I went to a rubber product manufacturer company talking about ERP implementation. They don't even have a proper process flow. But if you don't have a process flow, how do you want to implement an ERP? Because you don't know where to start. There's no workflow management, right? So process mapping and process flow is very important before you start any form of projects. So this is why some companies, they try to implement Industry 4.0, but they fail to implement. It's true stories that it happens, right? They buy technology, they implement it, but it failed. Now, the question is now, when they fail, are they going to continue to not invest anymore? Or are they going to pick up and say, okay, I have learned from my failure, now I'm going to make sure that it does not fail anymore, right? So then they know what other technologies that they want to implement. Yes?
Just want to check, what do you mean by process flow?
Ah.
You can make some examples, right? Because
Yep.
I believe in a factory, right?
Yep.
They will be able to run anyhow, right? So that definitely there is a process flow there.
Correct, correct.
So then, then what is the process flow that you are actually
Process flow would be more like workflow management. So, for example, like in your ERP, it's actually translating your manual process into digital process. So, understanding that process flow and that approval level processes or how it will move from one station to another is important to define first. So, without that definition, it's actually difficult to translate it to a software. Yeah, so that's why before we start any form of project, we always ask them, what is your flow of process that you want to start? And what are the kind of data that you want to collect in your shop floor? So these are the two things that we always define first. Yeah, so process mapping, mapping the process to the software. And what will be most interesting about is that a lot of software providers will always be, customer need to map their process to our software, not the software map to the customer. So if this mismatch happen, then it will actually take you longer to get used to it. Yeah, so this is one of the key problems. So that's ERP, digitization. Then you talk about analytics, right? Analytics only works or give you more benefits when you understand your data, right? So that's why you see the stage by stage, right? Visualization, storage, then you talk about formulation, then only analytics, right? So nowadays, analytics, you can also implement it from a drag and drop approach, right? So that you can actually see the process flow, you can actually see and estimate your production, estimate your next steps more cost effectively, right? Then of course, then only you talk about AI implementation, right? So AI implementation will talk about, utilizing computer vision. For example, let's say you want to find defects in parts, right? Most computer vision software are quite expensive, right? But today we actually make the software that we have open source for companies. So you can see it later in the lab. Later I will show you. So, and then, collaborative robotics are quite a trend now. So eventually you may want to think about implementing robotics, right? This kind of collaborative robot in your production floor. So certain industries will benefit from this because payload is only up to now is 12 or 16 kg as the biggest payload for the cobot. But I do know some companies that they actually don't need so high payload, right? For example, the plastic manufacturers, right? The products are not so heavy. So maybe you need 3 kg or less. Yeah. So then, you know, identifying which company provides you with that cobot will help you to actually scale up faster. So there are cobots that are as expensive as a Camry. There are cobots that are cheaper than a Myvi. So then you need to decide which one you want to invest in. Now, this is a very interesting question that I want to ask everybody today, right? You have layout 1, 2, and 3, okay? 3 different layouts in the factory, okay? I'm going to play the video. I'm going to ask the question, which layout do you think will give you the highest output, right? So you see the robot moving, right? 3 different layouts. Which layout do you think that will provide you the highest output? Right? This is always an interesting question that I ask a lot of companies. Okay? Do you need me to play back?
Yeah, one more time.
One more time, Okay. No problem. One more time, Which layout that you think will give you the highest output? Okay? All right. Ready for voting? Who thinks number 1 will give you the highest output? Put number 1. Okay, you have 3 for number 1. Okay. Number 2, who thinks number 2 is the highest layout? All right. Number 3. Okay. So let's continue to play back again. Maybe you might change your mind eventually. So this is what we call as the digital factory, right? It's really planning how you see your production before you actually commission it, right? Because sometimes you may want to invest in technology, but the placement of your products or the placement of your technology will also make a difference. This one is another set of robots that you can see, layout 4 and 5, I think. So this then brings the question, right? Can you actually visualize your production before you actually commission, right? So this is actually how it will look like. Correct? So you can see, some of you that say layout 1, you have 90.7 pieces per hour. Those that say layout 2, 193 pieces per hour. But those that say layout 3, you can actually achieve 204 pieces per hour. So virtual commissioning helps you to visualize your factory floor better and helps you to save costs and maximize your productivity. Why? Because you have more parts per hour. So you're generating more, right? Just by changing your layout of a machine, You don't even buy extra robot. It's just a layout change, right? So this is where it brings to the next question on the digital factory, right? So being able to simulate your production floor, being able to simulate your operator movement, being able to analyze potential bottlenecks, right, or potential idle stations. For example, we may not know, but the operator A and B, maybe A does more work than B, because B is always waiting for A, right, or C is always waiting for B. So visualizing this helps you to see your bottlenecks, helps you to balance your productivity, and helps you to minimize the gaps. So you see the digital tools that are introduced here is not for you to show nice dashboards in your factory. It's for you to see where are your gaps actually. Because by understanding your gaps, then only you can put in your benefits, right? So from layout 1, you see that, wow, it takes a long time to implement, 34 minutes to produce one part, right? Then you change the layout number 2, right? Maybe you change a little bit, you move the stations, you have a little bit more conveyors. Then layout 2, you have 23 minutes of a time. Then you move to layout 3, right? More compact, lesser, more compact with the same number of operators, right? With a better flow. Eventually, you can actually move from 34 minutes to actually producing a part in 8 minutes. That's a lot of savings, right? This is actually a combination of digital factory with lean manufacturing. Yeah, so we do teach, yes, hi.
Software for simulation for that.
Yes, yes.
That's one.
That's the software, yes. This software is called Visual Components. It's not free, unfortunately, but in terms of the scalability of this software, it's quite good. Yeah. So we decided on it because there was a catalog of 500 different equipments that is already in this software. You can just drag and drop. Otherwise, if you have your own design, then you can also use your own design. Yeah. So you can import design and a lot of features for this software. That's why we went on board of it. Yeah. So we actually have a program on this teaching you how to use it and implementing the lean concept to design your factory. Yeah. So actually we implement this is to, because sometimes when you do lean, yes, it's a fixed floor, right? But maybe you want to change layout and you can't keep changing physically all the time. So this tool helps to merge these two together. Yeah. We also have a lean manufacturing lab downstairs, a lean academy, we call it. Manufacturing a go-kart. Later I will show you also. A go-kart. From 40 minutes, we can cut down to manufacturing one go-kart in 2 minutes. But not by only using this, but physically, we train the students or the operators for the company from 40 minutes to 2 minutes. That's how fast they can actually change, implementing the lean methodology. So a lot of times, people think that, Industry 4.0 is about nice dashboards, AI, analytics, but the small bits and pieces is actually to realize that lean manufacturing concept. Yeah. Because lean, then only you make things sort of optimized, right? Without lean, you cannot optimize anything. So a lot of misconception, but hopefully we are able to clear that out today. Now, then when you want to see benefits, you first need to see the value of what you invest in, right? And what we mean by value creation means that you need to know whether you're investing in something that creates higher value for you, right? If there's no value, there's really nothing much that will bring you benefit eventually. So some companies talk about ROI. A lot of companies, ROI, return of investment. But the problem is sometimes the ROI guarantee is not as expected because the value that is created may not reach that kind of expectation of ROI, right? And ROI also depends a lot on your ability to actually get customers' orders and all that in, right? So what we look at is what we call as the payback period, right? So payback period, we look at the ratio of if it's less than 3 years, your investment is actually okay. If it's more than 3 years, you need to think again. Yeah, so this is why we always emphasize that we look at the payback period portion. So companies that implement technology with us, for example, right, the payback period is actually lesser, right? And I'll show you why it's lesser, okay? Now, so the step for digital transformation starts from the leadership buy-in first. Without the big boss saying, yes, we are going to do it, everyone else will not follow. Yeah, it's always the top-level management need to buy in first. And top-level management need to be involved in the process. It shouldn't be, okay, I appoint you to handle all the transformation strategy. It won't work. Most of the time, it may not work unless the guy who is leading it is truly passionate about building that transformation. Otherwise, it's probably going to be like that, straight, right? It's true story that we have had like engineers, people coming to see the smart factory. They say, yes, I want this in my factory. I think it's useful. Go back 3 months later, still quiet. Just quiet only. Then we say, okay, how about you bring your boss over, your CEO. CEO came, see, very good. Then he told the manager level for the engineering, in 1 month's time, I want to see this up in our factory. In the next 1 month, up already. Today, they have 14 plus machines all connected. So Leadership buy-in, very important. Very, very important. Then you talk about developing your ambassadors, your people, and then, of course, building your expertise, then you scale up. So it's in a way like a Kaizen approach of digitalization, right? So when you talk about benefits, right, it shouldn't be, I implement this, I have to see X amount of money come in or profit come in if I do this. It may not work that way. But you need to see, okay, if I implement this, what am I able to see, right, in my factory? Can I see the gaps? Can I see my improvement? Can I improve by 10, 20%, right? Sometimes it may not be profitability, but it may be more on productivity, right? Less by one head count, right? Or maybe, you know, we lessen the time for the supervisor to compile all the sheets and sheets of paper and put it into Excel sheet, right? Every single bit of a process that you can convert from a paper-based to paperless is cost saving already, right? Every form of that. So look at it from a Kaizen approach, small steps, right? We don't need to improve like big, like, okay, I want to see all the factory by next year, everything is digitized. Yes, that is the big picture. But start small, but scale big. That is the concept that we go with, right? And go with a level-based approach, right? Level 1, level 2, level 3, level 4, level 5. That is how you can see benefits from level-based concept, right? And this is actually, whatever you see level 1 to level 5, we package it into programs that you can join. So these are how we package it. And for companies, we actually help them to move forward to the next step through something called the Factory Technologies Framework, right? So how this works is basically companies would actually identify a team, right, to adopt Industry 4.0. They will then identify the right programs. Once they finish, they will identify a project, execute the project. Not so big one, not the factory-wide project. First pilot project. Project finish, company scale up on their own. So this is what we call as building a factory technologies in the factory to help you to digitize your productivity, because it just makes more sense from the perspective that they own the technology, therefore they know how much value it can create for your company. So that's why we went on this Factory Technologies Framework. Now, question is always, how much will it cost, right, to start, okay? Now, I took the next step also, because Kenneth also always asks me this question, right? I took the next step as well to break it down for companies. What can they see in terms of the investment, okay? Now, when you want to implement, okay, this is a bit small, but let me explain to you. If you want to implement, let's say you want to reach OEE, you want to digitize up to the OEE level, right? So let's say you take module 1 to module 4, okay? So investment would be more on the training perspective, right? Building up your talent capacity. So let's say you invest, each whole program, let's say is 73,000, assuming this is training only. But sometimes you have grants, like Rise Forward. Some companies apply for that, right? 25,000 off, you save some cost already, right? Now, next part, hardware. So hardware part is then, the next thought is it expensive? So it really depends on your implementation. If you want to do it one machine or you want to do it one line, right? One line meaning to say that your line needs to be close to each other. Otherwise, you cannot pull the wire. One machine, no problem, right? So the estimated cost around maybe 10,000 one machine. Less than that, actually, is about 8,500, right? Now, depending on the project scope, it is customizable. So for example, let's say you just want to implement up to data generation, just want to collect data, right? So your company don't need to invest up to OEE, you just need to go up to data generation. So maybe it's about, what, 12,000, right, for that module, for 2%. Then you invest the hardware, maybe it's about 8,000. That's 20,000 investment for first project, 20,000. Subsequent project, you only need to invest on hardware. That's all. Because software is already available, you just need to duplicate.
Your project here meaning one machine,
Yeah. Yeah. One machine or one process, depending on the company. Because sometimes the company can be quite ambitious. They say that, okay, I want to do entire process. They'll do. So some companies do that, some companies don't, right? So this is give you an idea of first project investment, a bit higher, but subsequently it gets lower or it reduces or becomes more stagnant. Yeah. Also depending on the project scope that you intend to achieve, right? But what some companies told us is that the project cost actually went down because they buy the hardware in bulk, so price is cheaper. Okay? So the idea is actually to save time, minimize losses, maximize gains. These are the three parts that we focus on, right? And those companies that implement that framework, they're very sustainable. They can grow on their own already. So they only come back to us when they need to learn new things, right? Because we also learn new things, they also want to learn together, so we do it together. So which companies have done it? Auto part manufacturers are quite common. APM is one of them. They have done a few machines as of recent. Theirs is quite interesting. Theirs is like I mentioned just now, it's one machine. Theirs is a whole production line. So theirs is a U-shaped line because the machines are designed in a U-shape. So they just identify 28 signals that they want to pull. So we tell them which hardware to buy, and they connect everything. Then the software they build, they finish a project in 10 days. 10 days, finish. One line. Today, they have already done 4 lines. Duplicate only. Now they cannot continue because hardware shortage. Yeah. Otherwise, they can continue to grow already. Yeah. So then, of course, the next other factories, I mean, they also are doing the same thing. They just duplicate.
They send people over here to do training.
Yes, correct.
They go through your 5 modules.
Yes, correct.
How many people they send?
They send about 2 to 6 members. Yeah. But this one, the manager was the driver for the projects.
But there's engineer inside.
Yes, engineers.
So
You need to have engineer.
Is very important in implementation of
Very important. Technical people. Yeah. That is also why in the classroom over at the end there, we have 15 engineers that we are training that already learn all the 5 modules.
What sorts of engineers that we are looking at to want to build this?
Yeah.
Like, those engineers that you are training, they are
Yep.
mostly fresh grad, right? So
Correct.
they don't really know about manufacturing
Yep.
per se.
Yep.
Like they don't have hands-on experience.
Correct.
So
Correct.
then, will they be able to deliver?
To pick up, right?
Yeah.
Yes, correct. So that part is also what Kenneth and Veronica always share with me from the SME perspective. And we do know that there is such a problem. So what we also came up with is that if you want to hire an engineer here, which we highly encourage, if you want to save a bit of cost, we actually encourage the company to at least attend one program, technical program, so that you know how it's implemented, first step. So then after that, what we can do is we can help to mentor that engineer to help you to implement the first project so that they have a bit of hands-on exposure.
But would you suggest them to actually go down to the field to experience the manufacturing?
Yeah.
Than when you start the project?
Yes, they need to know what the manufacturing machines are all about. That's important. But it's also important for the company to have at least one staff that knows how it works. Yeah, how the software works, how the implementation will work, so that they can guide or at least serve as a guide to make sure the project complete. Yeah, we tried before to just train an engineer and place them in the company. without the company knowing how it works, right? That means attend a technical program, it didn't work. Yeah, I will tell you it didn't work because, number one, company did not know what it's all about. Number two, the student is trying to explain to the company or convince the company that he knows how to do this, but companies still don't believe him. So that's why the mismatch happened. So we also try and error, right? So that's why we say, okay, this part don't work already. We identify the root cause. Now, to fix that root cause, company needs to at least know what is going to be implemented. Yeah. If you need any other additional resources, we have a YouTube full of videos that you can watch. If you have any questions at all right, just ask me, okay? No problem, man. You can ask anything. My name card is here in case you need to reach me via mobile. Yeah, so any questions you can just ask, no issue.